Hopefully this is live. Let me double check. Yes, it appears that it is live. So today we have something a little bit different. Okay, this is live. So today we're going to be taking a look at a shoulder receive coil for a MRI actually. Basically what this is an antenna. So this isn't anything too crazy. This is basically just a antenna. So first thing I'm going to check is the plug right here. So here is the plug. So here's the plug. Basically it has a bunch of coax, little coax connections similar to what you would find on a Wi-Fi antenna. And inside of here is just a few capacitors, some diodes, stuff like that. So let's open this up and we're going to check everything. Common things on these aren't really electrical failures. A lot of it is from drop. So broken traces, could be bad ceramic capacitors. Various things can happen, but they're not too complex, honestly. Yeah, so in here we have a few coils, we have some capacitors, a couple resistors, coax cable. So let me show you guys real quick. I'm going to go to the microscope. So let's go to the microscope. And for watching, that is low viewership. I think what happens is, I don't know I say this every single time, but a lot of times the notifications don't go out to most, honestly. It'll go out to like a third of the people, unless they all have notifications off, I don't know. Okay, so microscope. Let me put my OBS window back up. Random LCD connector. So what's in one of these? So this is, I'm going to switch to the 0.5 Barlow lens just because it would be better suited for this. So let me put that on. This stuff is bigger, so we don't really need that much magnification, and I'd rather have the increased working distance. Okay, this is better. So what's in one of these? So these are all coax connections for RF, of course, because that's what a MRI uses, is RF. Really basic stuff, as you see. It's just a coax connection. Now this right here, let's see, I need either more or less zoom. I need a little bit more. Let me adjust my microscope again, because it's set up for the 0.7 and not the 0.5. So I'm going to raise it up. Okay, so like I said, we just have some coax connections here. Have a diode, couple of coils. That's all these are, just coils. Few capacitors. Now that's these are just most likely smoothing capacitors, but they still are extremely important in this application. So as you see, it's just nothing too crazy here. This part right here is not shielded, but I don't think that's going to make a difference. That doesn't look like it's been messed with in any way. So I'm going to go ahead and start checking the coils. I guess sometimes they can break. And the capacitors and obviously the diode. But visually, I don't see anything wrong. I doubt we'll see it visually though. These are unused. No sign of anything. A lot of times ceramic capacitors like this, if they go bad, you'll see a crack in them or discoloration, and none of that's visible here. A little bit of flux left over from the factory, but that's about it. The resistors look okay. Alright, so I'm going to go ahead and start checking some stuff. Do you know how much it would cost your customer to buy a replacement from that? Depending on the coil, could be anywhere from $300 to $100,000. This one is not that expensive though, I'm sure. Let's see. I'll look it up in a minute, but yeah, they can be pretty expensive. So the first thing I'm going to do is check coils and check to see if we have continuity across the capacitors, which would not be good, just like on a MacBook. Okay, so that coil is good. That one's good. So 1 ohm across this. I don't know if that's normal. 1 ohm across this. Again, that could be normal, but I don't know. I don't think so. But let's continue. Okay, so this side is also the same, so that I would say is normal. No issue there. But not on this one. That's interesting. I'll probably have to take that capacitor off and test it. Diode. Believe is fine. Switch to diode mode. The diode is indeed perfectly fine. That's about it. And there's nothing on the other side. Let's inspect these solder connections right here. Don't see any cracks. That's honestly not the best soldering for like that one looks a little cold, but not, you know, a little bit of oxidation on it. I'm gonna check these resistors now. That one's good. That one's good. So I don't see any issues here. I don't think these capacitors are bad since both sides are the same. So I'm gonna go with this part of it's fine. No need to take this board out because there's nothing on the other side. And traces, let me double check traces. Breakage in a big trace like this is incredibly rare. I agree, Dennis. Yeah, and some of them you'll see capacitors stacked and such. It's quite amazing. Especially for what it's used for, too. Okay, so I'm going to go ahead and put this cover back on since I don't see anything wrong here. Sometimes these plastic covers can be a little bit funny to put back on because, like, if you see when you put it on, let me show you guys. So, you see how from the ones I've taken apart, this has happened. See that screw hole right there? See how it's not totally lined up? So it's just one of those things. If the board moves a little bit, see how the board is, there's nothing holding this board in. It's just in there from the coax connections. And two screws that are plastic, and it allows that give in it. So sometimes you have to move the board a little bit so that screw will line up. It's not the best, but that's how they are. It kind of holds the board in when you put the cover on. But considering what it is, you know, I mean, it's an incredibly simple device, as you could see. Okay, so this is the plug. This is going to connect to, I'm going to switch off of Microscope. So this is going to go to this part of the coil. Where this goes, I have no idea. And then this is the actual part that would go on your shoulder. And we also have to check this. So yeah, it's a pretty simple device, and it's just connected with coax connectors or coax cables. So I'm going to take apart this part of it now. So this one might be a little bit different. So this looks like it's held in by a few screws, and it is taped together. This is bad. Do not do this. And this is that stupid sticky tape for IVs. Why it's taped together, I don't know. It's probably taped together because it's going to fall apart. And this is... Actually, I don't know why it's taped together. I should probably clean this too. This is a pretty nice meter. So this is my new Flir Meter that I bought the other day. It has obviously a multimeter, and then it has built-in thermal, which is really cool. So yeah, I like this meter, and it's the thermal part of it's actually pretty decent resolution-wise for what it is. So yeah, I'm gonna do a review on that meter, but so far I like it. What was that? I heard like a beeping. There it is again. I really wonder what that was. Was it my audio interface? There's no smoke detectors in here. Is it? It's not the meter. Oh, it's the this thing. My rechargeable battery charger. I don't know why it's doing that. No, it wasn't not that. That's weird. I don't know what would make that noise in this office. Arnold is here. Joe is here. Kitty Strafe is here. Justin is here. Okay. So. Yeah, that's really strange. I'll have to find what's making that noise. It's like an alarm of some sort. So these are just screws. Plastic screws. Then under this cover is going to be an antenna. Well, not an antenna, but it's going to look similar to what we took apart in the other one, but should be just about the same. Monoxide alarm? There's nothing like that in this office, Joe. There's no fire alarm. There's no carbon monoxide alarm. Nothing. It stopped now, so that means we could ignore it. I don't know why they taped this thing together. There's no reason to tape it together. It's not going to fall apart. That makes no sense. Now let's see. Dropped one. I'll get that in a minute. And it's still held on by another piece of tape. There's no reason to tape this thing together. Makes no sense to me. This isn't normal tape. This tape is evil tape. It's not the same as like Captain tape. This stuff is incredibly sticky. And it traps dirt and it gets really gross. Is that my chair? There's nothing that would make that alarm. I don't know. Okay, so you can see in here how incredibly simple of a PCB this is. This is it. That's it. There's a couple diodes down here. There is an inductor. There is trace or a connection to this antenna. There is a couple capacitors here. There is this looks like some sort of coax connection since it's threaded, but there's nothing connecting it, so I don't know if that's something that's unused. That may be something that's unused, I'm not sure. There's a couple more capacitors here. There's an inductor, like I said, and there's a coax connection. And a few more capacitors on this side and 2 diodes. So this little board, let's take, do I want to take this whole thing off? No, I could check everything from in here, actually. It's all accessible. So again, we're going to start with capacitors, or I guess whatever's easiest to go for first. So, capacitors, right here. We're going to measure in diode mode, see if there's continuity across them. There's not, which is a good thing. That's good. See, I don't really know what this thing is. I'm guessing that's unused, honestly. I don't think that's even used. No continuity across these. Let's actually measure these. Probably have to take these out of circuit to measure them. And these do look a little bit discolored to me. Those do look like they got a little bit hot. But no, I don't think so. These are like, I think nanofarad too. I think these are okay. Check this inductor. Diode. Can move it out of view because it's easier for me. That diode is good. The other one is good. I think there's some caps on this side. There's a potentiometer or something right here. I'm not going to mess with that. So these caps are all connected to each other, so we don't need to check them all individually. But these seem good. Check them again in diode mode. Have a reading across them, but that's not a big deal. And it's normal with the other side. So that is good. So everything on this end of it checks out. Don't see anything wrong here, so I'm going to go ahead and put it back together. So these are all the same size, so it doesn't matter. You don't want to over tighten these. They're plastic screws, and there's really no need to go that tight on them. If you go too tight, they can twist and break. So a lot of from what I understand, if a diode is blown, it's not going to work at all, but if you have a blown capacitor or a failing capacitor, you'll get scan artifacts and stuff like that, as those are primarily involved in filtering. So completely dead would also be a bad trace, but mostly diodes, I'd imagine, because those traces are big and I don't see them failing. Sometimes coils can go bad when there's a break in the line or something, but that's kind of rare. And these are incredibly simple, so I don't really see many of these failing because they're just so incredibly simple. There's no ICs or anything in them. They're just simple. Now the next part is going to be a little bit more complicated, but we'll get there. It's honestly nice to work on something different than a MacBook for a while. Eventually I'm going to be doing, if this will pick up enough to where I'm getting a lot of them in, and they're fixable and not have nothing wrong with them like this one, then yeah, this would be nice. Okay, so we have the same thing. We have a few screws. This is Velcro. We don't want to mess with this. So same thing, same kind of screws. Pure novice here. And no, this is definitely not a Mac. Come on. Okay, I think that was all the screws, unless there's another one down there. I don't think so. This should pull up, I think. Let's see. a little bit trickier. It's because of the angle, but it should pull up like that. Oh, it's taped again. Darn tape. I'm going to clean all that up before giving it back to the customer, of course. Okay, so this is the other part of it. Again, largely the same. Let me show you guys. So again, this is largely the same stuff, different configuration. We have a couple more potentiometers. We don't want to mess with those by any means. If you mess with those, yeah, that would not be good. So visually, everything looks okay right here. I don't see anything wrong visually. But let's look under the microscope and start testing stuff again. So let's move over to Microscope View. Again, same thing. This is just as part of the antenna. There's nothing really here. And I think these are actually potentiometers as well. That's what I think they are. I don't know exactly. We have another part of the antenna right here, which is a copper tube. Now, RF in high power applications is only going to travel on the surface of something. So if something is high power, such as radar or something like this, they'll use a hollow copper tube like this, and what this allows is the RF is only going to travel. So even if you have let's say a solid copper tube, right? The RF is only going to travel on the very surface of it, so that's why they would use a hollow tube like this instead of something solid. And obviously weight, but that's what that's for. And we have, as you can see, another capacitor down there for smoothing. I think it's for smoothing, but it's the same concept. So we're going to check down here visually, see if we see anything wrong. I don't. We're going to check those diodes. The diodes are the most important part of this. So let's check these diodes. That one's good. That one's good. Checking diode mode across these caps. Good, 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 good. So far, all seems well. Let's check this cap down here, or up here, doesn't really matter. Aha, look at that. Is that broken? Sure is. There we go. I think it's broken. Let's see. Yep, there's our problem right there. That's why you don't work. Let me check this side just to confirm. Yep. That's some nasty oxidation on there. Get rid of that too. That's why you don't work right there. So in this case, what was probably going on is they're getting some scan artifacts. That's what I would imagine. Let me see if I could find an example of that. Actually, give me 1 second. Alright, so let me see if I could find an example of what I'm talking about by scan artifacts. Here's a good example. Okay. Okay, so artifact is right here. See this? That ain't normal. That's, that's an artifact. So what that would most likely be caused by is something like this in the coil. So we see we have a break in that line. Now there is, well, we'll see if there's a need to replace that capacitor, but I don't think so. I believe that it's just this. So we can actually test that in circuit. So let's check that cap right here. Open line. Open line. So what we're going to do is get our iron in here. We're going to put a nice little solder blob right there. Now it looks like there may be another cap underneath, but that is also broken. So what I'm going to do is I'm actually going to remove that cap in order to take care of the other one that is underneath. So let's do that now. And turn on the fume extractor. Now these are ceramic capacitors, so orientation does not matter. We're going to get our iron up here. We don't want to melt any of the plastic around it. And we don't need 740 degrees. This is not a MacBook. This is something much simpler than a MacBook. A little flux in here. I just want to melt the solder a bit. Oh yeah, look at that. Another break too in that. May actually need a little bit more heat than 540. I guess I will go 7. That's not going to hurt anything. Oh, you guys can't see it. There. So, just want to melt that solder. Can't use hot air. The tube is soldered in. Fumes. So, think how I'm going to get this one is I'm going to add some more solder. Or what I can do I want to take it off of that. I want to take out this little PCB. So we can see this is broken. I want to see what this is for. But I don't think I'll get that out. And I don't want to damage it. So since I don't want this to connect, but we see we have 2 broken traces there. I'm going to switch to a smaller iron. I'm going to switch to my J-tip because I kind of want the flexibility of the J-tip to be able to get around in that bend right there. The J-tip is nice for stuff like this. Put a little bit of leaded solder in there. And yes, in this application I believe they use only leaded and not lead free. So now I have a decent amount of solder on there. Come on. Got the plastic a little bit there. It's kind of hard to work in that small of space. I wonder, should I take this whole tube out? I hate the smell of burning plastic like that. Okay, so let me grab a better pair of tweezers. So I can't really grip it well. That makes no sense. There's like something else holding on to this guy. Alright, I'm gonna desolder it from the tube here, if I can. Is that copper a raceway for wiring? No. Not at all, actually. Okay, so I think I know what's... I feel like it's connected to that other cap, but I can't really tell. And you're working in this space, so see that? That's my finger, and I'm trying not to melt the plastic. So it is soldered to that other capacitor, and that is why it doesn't want to come out, from what I see. So I'm going to try and do... Okay, so I'm gonna grab some copper tape or Captain tape. Captain tape should work just fine. And I'm gonna line the edge of that so I don't burn it anymore. And I may see if I have an iron with a longer tip. By longer tip I mean, you guys know what I mean. Like this one right here. So this is going to allow me to get in there more without touching the edge. Yeah, I'll just try this instead of taping it. Can you apply heat to the backside? No, this is all plastic and this is gonna melt, unfortunately. So what I'm gonna do is get in here, attempt to, and this is connected to the same thing, so this would be an excellent place for hot tweezers. How is the tube connected? The tube isn't connected to the plastic, but the tube is connected to other stuff. And you know what? The tube is held in by plastic that has been ultrasonically welded right here. So that would be a little bit of a pain to get out, and I don't want to deal with that. So let's see. I may have to. Yeah, you know what? I do have to take this tube out. That's gonna suck. Because that is too hard to get in there. It really is, so. Alright, so yeah, I'm gonna have to take this tube out, unfortunately. That's no fun. So that is soldered here. That is soldered here on the antenna. So I gotta, actually, you know what? Is this soldered in? It is, these plastic things, but I should be able to pop these out. And we'll figure out a way to attach them later. These are for the screws. So we don't want to crack these or anything. I don't think we will. Just have to kind of break the solder joint. Oh, and see, someone's been in here before, as you can see, and this is actually super glued in. Nice. So now that's super glued in, that's going to make our job a lot harder to get this out. So yeah, someone's been in here before and super glued this together. Unless it's, no, that's not. That's super glued from someone else. I know factory would not. If the factory was going to do something, then again, crazier things surprise me already with these things. So I'll switch to the other view so you guys can see what I'm doing. So basically I'm just trying to break the super glue off of these things. Which is kind of difficult. If I use acetone, it's going to melt the plastic. But if I heat the plastic just a little bit, not enough to melt it, that may help us along. So like 100 Celsius from far away, just to soften it a bit. Yeah, this is a real pain. This is like Apple stuff, but worse. As far as doing stuff to, can you undo the one side and pull it out from the other? No. Unfortunately, no. It has to pull right out. I see what you're saying, though. But no, that would not work, unfortunately. This would have been fine, because I don't think these were super glued before, and then whoever worked on it last super glued it together, which is really nice. You know, you would think sometime the medical industry would be better than MacBooks, but it doesn't appear that way. And look, I bent my tweezers pretty good. It's okay. You know what, screw it. I'm not going to be able to get it. Not when it's super glued together like this. So now that leaves the only point, the only way, is doing it in here. So What I'm going to do, I think, this plastic is fairly pliable. I'm going to put something in there to kind of spread it out a little bit. Not enough to break it or crack it, but enough that I can stretch it. But Joe, if I use acetone, it's going to melt the plastic since it's a really soft plastic. So I can't do that. But what I'm going to do is I'm going to figure something out to jam in there to open it up a little bit. So I can get a little bit more space in there. So what am I going to use that? I don't know yet. I'm going to find something and I'm going to be right back. So let's see what I have. I need two things of the same size that can be jammed in there. Jam them in there, spread that plastic out a little bit, and one second. Some guy went and tugged at the door and then went to the next door and tugged at the door. I'm not opening the door for him. I want to get out of this place. Okay, so this may be a little bit too big. Don't want to use a battery, but I guess I can use a AAA battery. Let's see. AAA battery is about 1 centimeter. This is about half a centimeter. Nope, not going to work. May need to invest in a special clamp or something for that. Or figure something out. But I'm going to use what I have at this minute. See, a couple MacBook speakers. This works. Perfect. I think, anyway. Let's see. That's not going to give me enough room, though. Alright, I guess I'm just going to... I mean, whoever worked on it last really shouldn't have super glued that. Because, you know, stuff breaks in the future. Because there's no way. Unless you know what? Let's try and lift this out of here. The whole tube out of here. Since it is all loose. Nothing's really holding that in. It's copper. It can bend. So let's try that. It's just hard to grip it because... well, you guys see where it's at. You know what I think I just did, which actually works out perfect. I think that other solder joint to the other cap broke. So now, should be able to lift this up. Could clearly see the break in it. Yeah, those are not connected. So I'm gonna try now. Grab a hold of this. I don't get what holds these in. Let me try and remove this little PCB. This is actually a real pain, honestly. Just because everything's in the plastic, but I could see this happening more. I want to pull this little substrate out. If I desolder this copper from... Yeah, I'm gonna desolder this tube from down here just to give me a little more flexibility. Let me do that. It's kind of big to put in frame, so... Could already see the comments in this video. You shouldn't be working on this. BC2 is not going to work. I need a BC3. Or this giant knife tip. So I'm going to take off this connection down here. And it's a nice time for my iron to want to fail. I've had this Hakko for 3 years now. And I think it's starting to die. I think just the iron piece that's dying. Maybe it's hot enough. There's a lot of thermal mass there. 840 max temp. Some needle nose pliers. And that Hakko is dying for sure. It's not allowed to die yet, so it's not gonna die yet. No, Hakko, you can't die yet. Stop beeping. Thing's just gonna beep and beep and beep. That's okay. It's still hot. That's all that matters. Using my wick to kind of get rid of as much solder as I can. This tip may be bad, I don't know. Alright, whatever. My ears hurt. Shut up. Silence. There. Alright, so I'm not going to take that off. I'm going to just continue working in this area and just deal with it. Since these caps are all connected to the same tube, I think it may be better just drop some solder down in there. I don't know, since it doesn't want to seem to come out. I don't want to overheat this cap either. That wouldn't be good, but ceramic caps are usually fairly tolerant to heat. So we should be alright with heat-wise there. Got it. Almost. There we go. One is out. Perfect. This one, let's see. I'm gonna wick this up, clean this area up now. Yeah, that was kind of a pain to get that out of there, honestly. And now we're gonna clean it up and make it all nice and professional. Alright, so we see this side is connected, right? We see that's connected to that cap. I don't know if this is... wait. Yeah, that should be on there. That's fine like that. Just gonna push this down so I can get a nice solder joint on this one down here. Just like that. I don't trust these things right here, right? These connections, so I'm also gonna run a couple wires to that just in case there's a break or, you know, just be on the safe side. That's not a nice looking joint. Center the camera, please. I'm not really too concerned about that. But here. I'm just streaming because I want to. Oh, are you kidding me? I just punctured a hole in the side of my flux with my iron. Oh well, it sealed itself. So if I have the camera centered for me, I can't really see well. So if it goes off, if it's bothering and it goes off frame, if I move it, there'll be other streams of something you would enjoy, I'm sure. That's a good enough connection for me. Now this tip is not going to have the thermal mass needed for soldering that PCB part back on, so what I'm going to do is switch to the big tip again. That's going to be loud and beeping, but the ultrasonic solder clips is no longer moving. I don't know. There's 1, 2, 3, 4. There's like 5 of them. So if one, I need all 5 of them. I'm gonna try and melt solder since it's connected on both sides. Put some flux. I am going to touch the iron down here on the copper. Ensure we melt that. It looks good to me. Those caps are connected. This side is also broken. I'm going to use my small tip again just to add some solder down to where I need it, and then we'll use the big tip to heat the tube and actually melt it into place. What is that copper pipe? No, this is part of the antenna for an MRI head coil. So it is, I mean not a head coil, shoulder coil. So yes, that is copper. It is a copper pipe, but it's used for transmitting RF. Get down in here without burning the plastic. There. Let's get some more. No low melt. We can't use low melt for this, unfortunately. Yeah, it's not big enough. Need a good amount of thermal mass for this. You need like the micro soldering tips to fit down in there, but then you need ones that actually have the thermal mass to get in there. I'm going to use my wire cutters. I'm going to spread this open gently without breaking it. And you get the plastic every time. Alright. Guess I'm going to go back to the knife tip. But 200 Celsius will melt the plastic, Joe. This is what I'm gonna do. Get a nice tin on here, if I can. Is it ABS? I don't know. So hopefully with the flux it'll allow me to kind of tin this. Let me go at it this way. There we go. Alright, so that's connected to that little PCB now. There's this little thing. I took this off for a reason. I want to get that other cap in. This is not touching anything. These don't matter if they touch, honestly. So as long as we have a good connection. Here's our other cap. I'm going to clean this guy off a little bit. I'm going to flush that whole area out with flux remover when I'm done. Then have to test. But in order to test this, you need a magnet, and I don't have one here. And I don't mean a refrigerator magnet. I mean a big magnet. I'm pretty sure I don't have room for one of those in my office. And I'm pretty sure someone would complain about the noise, because it wouldn't be soundproofed. And they'd also probably have stuff get stuck to the wall for no apparent reason, because I probably wouldn't tell anybody if I had one in here. Okay, so we're going to test this while it's out on my meter. I don't want to put a bad cap back in. But I think it should be just fine. Visual inspection, and that looks like it had lead-free solder on it. It doesn't look too bad. But we will test it. So we don't want it to be bad. So first I'm going to test in diode mode to make sure it's not shorted. It is not. And then I'm going to test capacitance mode to see if the Flir of this meter will even pick it up. I don't know what the value of this is, and it is not picking it up. have to let it charge a minute. It's climbing. 0.06 nanofarad. I don't know what these are, but it should be fine. So I'm going to put this guy back in now. I'm going to clean it with the iron a little bit first. So it's nice and clean. I kind of like how I bent my tweezers. They're kind of nice now. It's a good enough amount of solder on there now. Make it sort of straight. It's good for me. Now we gotta get this guy here. And this is gonna go where it's making contact to the cap, like that. Maybe a little bit lower. That's fine. And I'll push it down here. Make contact. Come on. There we go. Looks good to me. Touch that up again. I'm going to remelt that with the big tip. Ow. I just did something incredibly stupid. I just tried to push the tip in and it was scalding hot. That was incredibly stupid. Do not do that. This looks good to me. I'm satisfied with it. It's not that pretty, but, you know, it's fine. It's making a contact. Nothing on the other side is melted. This side, which is the factory side, let's see. Anything broken there? Don't see anything. Actually, I do have a little break there. See that? Broken trace there. I mean, broken, so this had to have fallen, and when it bent the pipe. So, yeah, that's a break there. These caps don't look broken, or do they? Maybe. Maybe they do, maybe they don't. That side is reflown. It's kind of hard not to melt the plastic a little bit, so I'm not too concerned about that. No one else is going to see it. I know it's off center, but it's going to have to be okay for right now. Excuse my ignorance, what are we working on? Exactly what the title says. This is a shoulder coil for a GE Signa MRI. We look connected in there. Can't tell though. Yep, that's definitely connected. I think it's connected on that side too. I'm gonna stick something down in there to confirm. Yeah, we're good. Alright, I'm gonna flush this out with some cleaner now. Should I flush it out with some cleaner? Let me just make sure it's not gonna melt. I'm gonna spray a little on a Q-tip and on the plastic just to make sure it's not gonna screw it up. Nope, we should be fine, so I'm gonna spray a little flux cleaner in here. And that should be much nicer and cleaner. Looks good. Looks good. Not the prettiest thing right here, but it's making a contact, and it should work just fine. So, that's it for today. Thank you for watching, and I will see you in the next stream.